Good morning, good afternoon, or good evening. Welcome back to the channel. I hope you are all doing fantastic. If you are watching this, you are obviously interested in Cisco's Catalyst SD-WAN, and you have come to the right place. This video is part of a larger SD-WAN series and is focused solely on onboarding Cisco Edge routers to the SD-WAN fabric. So with all that being said, let me share my screen. Now, again, this video is part of a larger series, so if you were watching in order, I just got done a video where we brought up all of the controllers into an SD-WAN environment. So what we're looking at here is Catalyst SD-WAN Manager, and if I go to Devices, we can see that we have a manager and validator that sit in AWS, 3 controllers that sit in a Data Center 1 facility, and 3 controllers that sit in a Data Center 2 facility. We're working through some SD-WAN design docs, but let me show you the overall topology as well. So for the purpose of this video, in the bottom left here, we have a San Jose, California Cisco Edge router that is an 8000V. It's a Catalyst 8000V running inside of Cisco Modeling Labs. It's been deployed as just that. It should be in autonomous mode, which is iOS XE. We're going to convert that to controller mode. We're going to authenticate it with a certificate using DTLS to the fabric. We'll put a base config on it, and we'll get this router ingested into the manager. I'm going to hopefully show 2 different ways to do it. One is through syncing a smart account that has a bunch of instances of an 8000V already in the inventory, and the other way will be to do a PayG instance. So let's hop right in. I've just started the San Jose router and I've just started the RTP router, so they should be booted by now. So San Jose looks like it has certainly been uh, finished booting, so we can see it literally just started up. Same thing with RTP, Research Triangle Park. It looks like that box is up and ready for us to do something with. So the first thing I'm going to do is, again, if you were following an order, I used a Windows Server CA to basically do all the certificate signing that we brought up the controllers with. So I've saved that root certificate, and we're going to need that to put onto the flash of these routers. So what I've got here is kind of a cheat sheet script that we're going to work our way down. But the way I'm going to do this is I'm going to use a TCL shell to essentially write this contents, which is my root CA or my root cert. I'm going to basically put this on the boot flash of the router, and I'm going to save it as this name, xlan-root.pem. That's all that's all that this config does. So I'm going to just take this and I'm going to copy and paste that actually onto both of the routers. So I'm going to do the same thing on the RTP router. Now that that file is on the boot flash, I'm going to go ahead and convert both of these 8000Vs into controller mode. So before I do that, if you're not sure which mode you're running in, you can simply do a show var. You can either do show var or you can pipe include mode, and it should tell you what the router operating mode is currently in. So in my case, it's autonomous. So if I put that same command over here, we can see it's autonomous mode. So the command that I have highlighted here, controller mode enable, what it's going to do is it's going to force a reboot on the router. And upon rebooting, it's going to launch in controller mode. So when I put that command in, it says enabling controller mode will erase the NVRAM file system and reload the box. Do you want to continue? Yes. Then it presents a warning. It says there's no day 0 bootstrap configuration. Do you want to abort or do you want to continue? I'm going to say no because I do not want to abort. So I'm going to do the same exact command on the RTP box, confirm, and then no. So that's going to obviously reboot both boxes. It's going to take a couple minutes for that to happen. So while they're rebooting, the next command that we're going to run is essentially a command that takes the contents of that file that's in the boot flash and installs that certificate. Okay. So it's request platform software SD-WAN root dash cert dash chain install, and then you point it to the directory of the boot flash which contains that file. So this is going to be the first command we run once the router's back up. And what that should do is install the certificate. We can then run the show SD-WAN certificate root-ca-cert command, and we should see some output that verifies that the installation of that certificate actually happened. So that's the next steps that we're going to be taking here. While those routers are rebooting, I'm going to highlight one other thing. So if we come over to SD-WAN Manager, if I go to configuration, WAN edges under devices, right now I don't have anything in my inventory. It's completely empty. Okay. So I'm going to do one thing. I'm going to pause the recording while I do it because I don't want to expose my smart account information. So I'm going to go ahead and sync my smart account so that it populates my inventory with those routers. But the other thing I'm going to do, so the idea is that one of those routers in the topology will bring in from an existing inventory serial number and token. The other one will do as a PayG instance. So that's why I started up two routers so I can demo both ways. So, but like I said, there's sensitive information on the smart account, so I just don't want to have to like blur and uncut and all that kind of stuff. So I'm gonna just sync it while I'm not recording and do it that way. And then the PayG instance will actually just do live together while recording. So I will see you guys in a minute. Okay, so the smart account has been essentially synchronized. There should be 21 potential chassis numbers that I can use to play with in the lab. So we're obviously not going to need all 21, but they're there to play around with. So the routers should be up after the reboot. So you can see there's this annoying smart licensing message that's just going to continually bother us. But we're going to have to just work through that for the time being. So if I hit the carriage return, you can see it's asking me for a username. So when you turn the routers into controller mode, you're going to want to use admin as the username and password, and then it immediately prompts you for a new password. So I'm going to go ahead and just put a new password in. It's going to ask me to confirm that. And then from that point, I can actually do stuff on the router. So let me do the same thing on RTP, admin, admin, put the new password in, and now if I run show ver include mode, we can now see the difference. I'm in controller managed mode. Okay. The other kind of telltale sign is that if I try to do conf t, it does not like that anymore. It says it's not supported in controller mode. You must use the equivalent, which is config dash transaction. So just be aware. At this point, we're going to go back to the cheat sheet, right? So we had said we need to actually install that certificate. So let's go ahead and do that. So you can see upon running that command, it says uploading root CA cert chain via VPN 0, changing ownership. So it's clearly doing something, right? Once it's done, we'll go ahead and run the show command. So when we run the show command, we should see some information that's indicative of our environment. So we can see that xlan.com was the issuer of the cert. So we know that that command was successful. We now have the xlan root CA installed on the box itself. So let's just, for sanity's sake, do the same thing on the other router. Okay, so we now see, right, xlan.com. So that's perfect. So what I'm going to do is put the base config on next, and then I'm actually going to reboot that router, both routers, because I just want to get the console to kind of clean up. So this is the configuration that we're going to commit to the San Jose router. So again, config transaction, we're going to slap a host name on. Under system, we're going to give it a system identifier, or it's like somewhat like a router ID. So based on our topology, San Jose is running the 10.3/16 network and it's site 103. We know that the organization is XLAN. I'm going to use a fully qualified domain name for my VBond, okay? And then the only interface we need to really worry about is the one that provides reachability to our VBond, which is gig 2, and it's the biz internet. Okay, so if we go back to the topology here, so in San Jose, right, I'm going to highlight the router. We have two WAN connections. Gig 1 is MPLS and gig 2 is biz internet. MPLS isn't going to do us any good right now because it's not going to get us connectivity up to AWS. So what we need to do is configure gig 2 for the biz internet, which will get us the connectivity up to AWS and be able to onboard this router into the fabric. So that's all we're interested in at the moment. So again, go back to the config. So nothing more than an IP address and a default route. And then for the tunnel, we're going to basically say, hey, build an SD-WAN tunnel using the gig 2 as the source and unnumbered interface. And the last piece we need to do is under SD-WAN. We just need to specify gig 2 as the tunnel interface. That's IPsec. And we specify the color, which again, based on that topology, is biz internet. So I'm literally just going to take this config and I'm going to copy and paste it onto San Jose. Now for RTP, let's just go ahead and modify it really quickly. RTP 10.4, site 104, 104 as the last octet. And that should be the only difference between this base config and San Jose. So once the config's on there, as I mentioned, I'm going to reload the boxes. One thing. There's one thing we need to do. Actually, it can wait. It can wait till after the reboot because I'm not going to try to configure it while the router's spitting these messages out at me. Okay, so I confirmed the reload on San Jose. Let's reload RTP. Okay, perfect. I'm going to pause the recording. I'll see you guys in 2-3 minutes once these routers are back up. All right, so the router's just finished rebooting, like literally. So I'm going to log in with admin and the new password that I created for both. Okay, so should be a lot less chatty now after the reboot. So The first thing we need to do is verify that we have connectivity to a validator, right? Or what used to be VBOM. So when we did the configuration, we used the fully qualified domain name for the VBond. So if we do show SD-WAN running config, we had put in include VBond. So we had put in the FQDN, right? So what we need to figure out is, can we ping on VPN 0 that address, right? Or should we should just try to ping that address? Okay. So we can in fact ping, we can resolve that and we can ping it, right? We know that it's got the address of 11.52. So let's go ahead and do the same verification on RTP. Okay, so we have reachability, so that's perfect, right? Now, there's one more piece to this puzzle. If we go back to Manager and we go to Configuration, Devices, WAN Edges, and let's just sort by reachability, we can see that we don't have any devices that are reachable, right? So even though we're able to ping, there's no, that router has not been ingested into the, or onboarded into the SD-WAN fabric. So this is where the two ways come into play. So there's a command that we need to run. So if we scroll down on our cheat sheet, we can see that there's going to be, and these aren't going to work. I need to get new ones. But we need to do the request platform software SD-WAN vEdge underscore cloud activate chassis number, and then right here we're going to put in the chassis number followed by the keyword token, and we're going to put in the token. All right. So the first thing we need to do is we need to get the chassis number and we got to get the token. So if we come back to Manager and we go to Configuration, under Certificates, WAN Edges, remember I synchronized my smart account. So I'm going to take the very first one, I'm going to copy this chassis number, and I'm going to put it into the command there. I'm also going to take this token and I'm going to copy and paste it into that long command. Now I'm going to take that entire command and I am going to paste that onto San Jose. So there's two things I want to do. I want to IP name server, I'm going to put in my CA, which is also running DNS. I'm going to do IP domain lookup. Let's commit that. Okay, so it's important to have these commands. That's what I was alluding to prior to the reboot. I need to get these in my script, actually. So you can see the router's doing something. It looks like new CSR was generated, so it's going to hopefully have that signed, which it looks like that's happening. Okay, perfect. So that looks like the cert was installed. Now, what we need to look at here is the verification command to see if the control connections are up. So the command to do that is show SD-WAN control connections. That has to be plural. It needs the S. So we can see the router's doing something. It's going to take a couple minutes for this to kind of stabilize. You see things going up and down. And there's going to be a key distinguishment that I want to point out here, and it comes back to the design that we're kind of working through. So if we go back to the documentation, so we were working through the design scenario where you can see the manager and the validator, in our case, is up in AWS. There's two data centers in the Cisco example here, west and east. We're no different. We have two data centers. And you can see the XE SD-WAN routers down the bottom. What they're doing is maximum control connections 2. And you can see they're splitting the control connections between the different group IDs or the different data centers. So that's what we're going to try to mimic with our lab environment here. So we know that on the controllers, we already identified which groups we want the various controllers to belong to. But what we haven't done is on the edge routers, in this case, they have an ISR 4331, and they're using this command, system controller dash group dash list, and then they're hard coding it to be 1 and 2. So that's actually what we're going to do as well. We're going to take this command, we're going to copy and paste that onto our edge. So config dash T, and we're going to commit that. We're going to give that another minute. And we're also going to take this command as well. Define the controller group list and configure the maximum number of OMP sessions to be 2. So let's go back to that box. And let's hard code that and commit. Show SD-WAN control connections. Okay, so this is what we want to see. So what we want to see is there's essentially 3 control connections, right? We have our v manage, okay, which we know is 1151 that sits up in AWS. And we can see that we have a 73 and a 63. So let's go back to our topology. Let me bring up, it's my bad, sorry. 33, let me go to. This is the zoomed in version of the controllers. So we said 63 and 73, right? So it looks like we're using controller 3 in DC1 and controller 3 in DC2 based on that output of the show SD-WAN control connection. So that's perfect, right? That's exactly what we want. We want to split the control connections between the data centers, which is exactly what we've just verified. Now, I need to show you guys how to onboard the other router as well. So he came back from his reboot, but obviously we have not brought him into manager. So if we go back to our cheat sheet, we know that we configured him. He should have reachability, but we need to do the DNS as well. So config T IP name server 172.16.11.10 IP domain lookup. Let's commit and show SD-WAN running config. Let me pipe include vbond. Let's make sure we have reachability. So let's ping vbond.xlan.com. Looks like we have reachability. So now what we need to do is go back to our manager. And by the way, if we go back to configuration, devices, WAN edges, So now we see San Jose is in fact in sync onboarded as site 103, right? But we used one of the chassis numbers that were essentially synchronized from the smart account. So in this case, let's add a payee. Let's just add one. Send the controllers yes. So let's go ahead and add that. Okay, so that was successful. Let's go back to devices. We should see 22 on the list, which I know it's small, but right here it's 22 now. And if we sort by chassis number, we now see that there's this payee instance or chassis number, if you will, right? So if we come back to configuration, certificates, WAN edges, and we look for that chassis number. So here's the payee. So let's copy that. Let's come back to our install command. Let's replace the old serial with that one, or chassis number, I should say. And then let's grab the token while we're at it. And then let's take that whole command and let's paste that into this time RTP. So interesting message that comes up with the payee is now it's limiting our throughput level. And we should see another interesting message actually as well. So it's doing the certificate. Looks like it's authenticating as we speak. So it installed the root. That's good. Here's the other one. So it's complaining now because we essentially used a bring your own license instance of a router, but we're trying to associate it with a payee license because we just generated that payee license. So it's a little odd that it presents that message, but what we should see though is if we do show SD-WAN control connections, so we do see that it's authenticating and it's coming up. Now, interestingly enough, we see 62 and 63, which again, if we go back to our topology, 62 and 63 are both in site 1, which is DC1. That's kind of against the design that we're going for because we didn't do the uh, system control group list or the max OMP sessions on San Jose yet. So, or excuse me, RTP. So let's go ahead and do that, and we'll see if we get a difference in output. So we're going to go ahead and basically limit the number of sessions to 2, and we're going to split those sessions between DC1 and DC2. So that's the first command, and then now 1 and 2. So let's commit. We'll give that a second. It should flap some DTLS tunnels here. At least I would hope so. Okay, so it looks like it flapped, took one down, so it looks like it's still thinking through it. Okay, good. So now, check this out. So now when we run the command again, we can see 62 and 72, which again, I separated the IPs on purpose to make it easily identifiable. but 62 and 72 are now split between DC1 and DC2. So this is awesome. This is exactly what we were looking for, right? So we're controlling the load balancing or the control connections, if you will, between the data centers. And the idea around something like this, right, is if you're in a production environment and you need to upgrade the code on your controllers, let's say, you can upgrade an entire data center, right? And you won't affect the control connection